A-Level Mechanics, an exercise based on centres of mass. There are 5 questions in this exercise, 3 on this page and 2 on the next page. Pause the video at this point and try the first 3. Then, when ready, restart the video for the next 2 questions. There are 2 questions on this page. Pause the video at this point and try them, then restart the video to go through the answers. In question 1, we're asked to find the centre of mass of the uniform lamina in the diagram below. Now, to solve this, the first thing we need to do is divide the lamina into 3 regular units. We can label these A, B and C. And then we can make up a table. Now, for the row headings we can label them A, B, C and then the total, A plus B plus C. And for the column headings we have M, X, which is the X coordinate of the centre of mass of each part, MX, Y and MY. Now we can let an area of 1 have unit mass, so the mass is equal to the area. The area of A is 0.8 times 1.0, so A has a mass of 0.8. The area of B is 1.8 times 1.6, so B has a mass of 2.88. Now the area of C is a square with a smaller square cut out from the centre, so the area of C is 1 times 1 minus 0.6 times 0.6, which means its mass is 0.64. And finally, the mass of A plus B plus C together is 0.8 plus 2.88 plus 0.64, which is equal to 4.32. Now we need to find the coordinates of the centres of mass of A, B and C. Now for A, the x-coordinate of the centre of mass is halfway across, so that's 0.8 divided by 2, or 0.4. And the y-coordinate is halfway up the rectangle, so that's 1 divided by 2, or 0.5. For B, the x-coordinate again is halfway across, so that's halfway between 0.8 and 2.6. So it's the average of 0.8 and 2.6, which is equal to 1.7. And the y-coordinate is half the height, which is 1.6 divided by 2, or 0.8. For C, the centre of mass is the same as the centre of the square. So the x-coordinate is halfway across between 2.6 and 3.6, which is the average of 2.6 and 3.6, which works out to be 3.1. And the y-coordinate is halfway up the square, which is a half of 1, or 0.5. We can now fill in the rest of the table. The x-coordinate of A is 0.4, and the y-coordinate of A is 0.5. The x-coordinate of B is 1.7, and the y-coordinate is 0.8. For C, the x-coordinate is 3.1, and the y-coordinate is 0.5. And for the total, we don't know what the coordinates are, so we'll leave them as x bar and y bar. We can now multiply the mass m with the x and y coordinates. So for A, we've got mx is 0.8 times 0.4, which is 0.32. For B, mx is 2.88 times 1.7, which is 4.896. For C, mx is 0.64 times 3.1, which is 1.984. Now for A, my is 0.8 times 0.5, which is 0.4. For B, my is 2.88 times 0.8, which is 2.304. For C, my is 0.64 times 0.5, which is 0.32. And then we can finally add up the sums of the mx's and the my's. So for mx, 0.32 plus 4.896 plus 1.984 is equal to 7.2. And for my, 0.4 plus 2.304 plus 0.32 is 3.024. Then we have x bar is equal to the sum of the mx's over the sum of the m's, and y bar is equal to the sum of the my's over the sum of the m's. So x bar is 7.2 over 4.32, which is 1.6 recurring, or 1 2/3. Y bar is equal to 3.024 over 4.32, which is 0.7. And so we have the centre of mass is 1 2/3, 0.7. In question 2, we're told a uniform rectangular lamina measures 10 centimetres by 20 centimetres. A circular hole of radius 4 centimetres is cut out with a centre 5 centimetres from one end and 5 centimetres from each side. Find the centre of mass of the remaining lamina. Well, to solve this, let the centre of the mass be x bar, y bar. We can mark that on the diagram, and since the shape has vertical symmetry, we can see y bar is equal to 5. Now, let the mass of 1 square centimetre of the lamina be unit mass. And let A be the circular lamina that's cut out. Let B be the remaining lamina after A has been cut out. Now the mass of A is pi r squared, so it's pi times 4 squared, which is 16 pi. And the x-coordinate of the centre of mass of A is 5. Now the mass of the complete lamina A plus B is 20 times 10, which is 200. The x-coordinate of the entire lamina A plus B is equal to 10. Now the mass of B alone is 200 minus 16 pi. The rectangle minus the circle. And the x-coordinate of the mass of B is what we're trying to find, so we'll call it x bar. Now we can use the formula x bar is equal to sigma mx over sigma m, or sigma mx is equal to x bar times sigma m. So for A, the mass is 16 pi and x is 5. For B, the mass is 200 minus 16 pi, and x is x bar, and for AB the mass is 200 and x is 10. So that gives us 80 pi plus x bar into 200 minus 16 pi is equal to 2000, and if we divide all the way through by 8, that gives us 10 pi is equal to x bar into 25 minus 2 pi is equal to 250. Subtracting 10 pi from both sides, we have x bar times 25 minus 2 pi is equal to 250 minus 10 pi, or x bar is equal to 250 minus 10 pi all over 25 minus 2 pi. And that works out x bar is 11.6784, so rounding that off to 3 significant figures, the centre of mass is 11.7 centimetres from one end and 5 centimetres from the edge. In our method for solving this problem, we started with a rectangular lamina and we cut out a circle of positive mass. An alternative method would be, instead of cutting out a positive mass, we could add a circle of negative mass. So, an alternative method to solving the problem is to consider the final lamina as a rectangle attached to a circular lamina of negative mass. Now the rectangle has mass 200 and the x-coordinate of its centre of mass is 10. The circle now has mass minus 16 pi and its centre of mass has coordinate 5. So using x bar is equal to the sum of the mx's over the sum of the m's, we have x bar is equal to 200 times 10 plus minus 16 pi times 5 over 200 plus minus 16 pi. That is 250 minus 10 pi over 25 minus 2 pi. So x bar is equal to 11.6784. And again we get our answer. X bar is equal to 11.7 centimetres and Y bar is 5 centimetres. In question 3, the diagram shows a box open at the top and front made from 4 uniform rectangular lamina. The box measures 15 centimetres long, 8 centimetres wide and 6 centimetres high. Each lamina is the same weight per unit area. Find the centre of mass of the box. Well, to solve this, let's draw some axes, X, Y and Z, and label the sides. We can label them A, B, C and D. Let 1 square centimetre of each lamina have unit mass. Now for lamina A, the area is 6 times 15, which means the mass is 90. And we've got the X coordinate is halfway across, which is 7.5. The Y coordinate is 0, and the Z coordinate is halfway up, which is 3. For lamina B, the area is 6 times 15, which means the mass is 90. The X coordinate is halfway across, which is 7.5. The Y coordinate is the distance back, which is 8, and the Z coordinate is halfway up, which is 3. For lamina C, the area is 6 times 8, which means the mass is 48. Now it lies on the YZ plane, so the X coordinate is 0. The Y coordinate is a halfway back, which means Y is 4, and the Z coordinate is halfway up, which is 3. For lamina D, the mass is 8 times 15, which is 120. The X coordinate is halfway across, which is 7.5. The Y coordinate is a halfway back, which is 4, and the Z coordinate is 0, since it lies flat on the XY plane. Now we have, for the box, X bar is equal to the sum of the MX's over the sum of the M's. Now for each lamina A, B, C and D, we've got the sum is 90 times 7.5 plus 90 times 7.5 plus 48 times 0 plus 120 times 7.5 all over 90 plus 90 plus 48 plus 120. And that works out to be 2,250 over 348, which gives us 6.4655. So X bar, the X coordinate, is 6.47 centimetres. Also, we've got Y bar is equal to the sum of the MY's over the sum of the M's, which is 90 times 0 plus 90 times 8 plus 48 times 4 plus 120 times 4 over 90 plus 90 plus 48 plus 120, which works out to be 1,392 over 348, which is equal to 4. So Y bar is equal to 4 centimetres. Now we would expect that the box is symmetric, and so we would expect the Y coordinate to be halfway across the box. The box width is 8, and so we get Y bar is equal to 4 centimetres. And then finally we have Z bar is the sum of the MZ's over the sum of the M's. So that's 90 times 3 plus 90 times 3 plus 48 times 3 plus 120 times 0, all over 90 plus 90 plus 48 plus 120, which gives us 684 over 348, which is equal to 1.9655. Or rounding it off, Z bar is equal to 1.97 centimetres. And so we have, our answer is the centre of mass is 6.4 centimetres from the rear end, 4 centimetres across, and 1.97 centimetres up. In question 4, we're told a hollow hemispherical shell with radius 6 centimetres is made from a thin plate of metal. It weighs 120 grams. The centre of mass of a hemispherical shell is halfway along the axis of symmetry. A ladle is made from this hemispherical shell and a thin uniform handle of length 32 centimeters and mass 130 grams. The handle is parallel to the axis of symmetry of the hemisphere. In part A, we're asked to find the centre of mass of the ladle. Well, to solve this, draw the ladle with the handle along the x-axis and the hemispherical shell vertically above it. The origin is at the intersection of the bowl and the handle. The centre of mass of the bowl is at -3,6, and the mass is 120 grams. The centre of the mass of the handle is at 16,0, and its mass is 130 grams. Using x bar is equal to the sum of the mx's over the sum of the m's, we've got x bar is equal to 120 times -3 plus 130 times 16 all over 120 plus 130. And that works out to be 6.88. Using y bar is equal to the sum of the my's over the sum of the m's, we've got y bar is equal to 120 times 6 plus 130 times 0 over 120 plus 130, which works out to be 2.88. So the centre of mass is at 6.88 centimetres, 2.88 centimetres. Then in part B we're told the ladle is suspended from the end of the handle. Find the angle the handle makes with the vertical. Well, the centre of mass will lie vertically below the end A of the handle, which we can see in the diagram, and we can draw this in the diagram above. The angle we want to find is the angle theta. Now if we look at the triangle we've just formed, the opposite side is 2.88 centimetres, and the adjacent side is the length of the handle, 32, minus 6.88, which is 25.12 centimetres. Looking at the triangle, we've got the tangent of theta is 2.88 over 32 minus 6.88, so theta is the inverse tangent of 2.88 over 25.12, and that works out to be 6.540. So the angle the handle makes with the vertical is 6.54 degrees. In question 5, we're told the letter F is cut from a uniform lamina, as in diagram 1. The letter I is cut from the same material as in diagram 2. In part 1, using the axes shown, find the centre of mass of the letter F. Well, to solve this, we need to divide the letter F into rectangles. And we can label these A, B and C. The base of rectangle B is 12 centimetres. It's a good idea to let 1 square centimetre of the lamina have unit mass. This means the area of any shape will equal its mass. We can now draw out a table. The row labels are A, B, C and A plus B plus C. The column headings are area, mass, X, MX, Y and MY. X and Y are the coordinates of the centres of mass. We can now fill in the cells. Well, the area of A is 27 times 6, so its mass, which is the area, is 162. The area of B is 6 times 12, giving an area or mass of 72. The area of C is 6 times 6, which gives an area or mass of 36. And if we total up the masses, we get 162 plus 72 plus 36. That gives a total of 270. Now we can mark the centre of mass of each rectangle on the diagram. Now the centre of mass of A is halfway across A, which is 3 centimetres, and halfway up A, which is a half of 27 or 13.5 centimetres. Now the centre of mass of B is all the way across A, which is 6 centimetres, and halfway across B, which is another 6 centimetres, so it's 12 centimetres across, and it's 3 centimetres down from the top, so that is 24 centimetres. The centre of mass of C is all the way across A and halfway across C, so that's 6 plus 3, which is 9 centimetres, and it's 9 centimetres up plus a halfway up C, which is another 3 centimetres, so that's 12 centimetres. Now for A, we've got x is equal to 3, so mx is 162 times 3, which is 486. Y is 13.5, so my is 13.5 times 162, which is 2,187. For B, x is equal to 12, so mx is equal to 12 times 72, which is equal to 864. And y is 24, so my is 72 times 24, which is 1,728. For C, x is equal to 9, and so mx is equal to 36 times 9, which is 324. Y is equal to 12, and so my is 36 times 12, which is 432. Now we don't know the coordinates of the total a plus b plus c, so we'll call those x and y. And the sum of the mx's is 486 plus 864 plus 324, which is 1,674. And the sum of the my's is equal to 2,187 plus 1,728 plus 432, which is 4,347. Now we have, for the total letter f, we've got x bar is equal to the sum of the mx's over the sum of the m's, which is equal to 1,674 over 270, which equals 6.2. And y bar is equal to the sum of the my's over the sum of the m's, which is 4,347 over 270, which is 16.1. So the centre of mass is 6.2 centimetres, 16.1 centimetres. Now in part 2 we're asked, if the letter F is suspended from the corner point A, what angle would side AO make with the vertical? Now we can mark in the centre of mass of the shape at D. When the triangle is suspended from A, AD would hang vertically. So we want to find the angle between AD and AO. We can call that angle theta. The sides of the triangle we've now got are 6.2 centimetres and 10.9 centimetres, which is the height of A, 27 centimetres, minus the height of D, 16.1 centimetres. So, we've got the tangent of theta is 6.2 over 10.9, so theta is the inverse tangent of 6.2 over 10.9, which works out to be 29.63. So the angle the side AO makes with the vertical is 29.6 degrees. Now in part 3 we're asked, if the letter I was placed to the right of the letter F to spell the word if, what size gap would be needed between the letters so that the centre of mass of the pair would lie on AO? Well, we need to draw a diagram and let the gap between the letters be x. Now, on the original letter I, the centre of mass was at 313.5. So on the axes, the centre of mass of the letter I will be minus 3 minus x, 13.5. Now we can draw that in on the diagram as the point E. Now the mass of the letter I will be 6 times 27, which is 162, and we can draw that in the diagram. Now if we mark the point D, which is the centre of mass of the letter F, we have the mass of F is 270, and the x-coordinate of D is 6.2. Now, using x bar is equal to the sum of the mx's over the sum of the m's, we have that's equal to 0 because we want the centre of mass of the word to lie on the y-axis. So that gives us minus 162 times 3 plus x plus 270 times 6.2, all divided by 162 plus 1,674 is equal to 0. So 162x is equal to 1674 minus 486, which is equal to 1188. So x is equal to 1188 over 162, or 7 1/3. That means the gap between the letters must be 7 1/3 centimetres.